Now, when we're measuring the linear association, our eyes aren't very good judges of linearity. That's why we need lines and we need other numbers to do it. And the number that we typically use is our correlation coefficient. That's our R value. Now, our R value we're going to use extensively in this class. The tough part is trying to figure it out because this is the equation. 1 over n minus 1 is the sum of each x value minus its mean over its standard deviation times each y value minus its mean over its standard deviation. So I'll do a quick example to help you out. So say we have this x and y variables, and we want to find the r value. So first we have to find the mean of x, the standard deviation of x. Find the mean of y, standard deviation of y. And we can do that with a two variable statistics, which if you want to ever do that, you just hit stat, go over to calc, go to two variable statistics, go down to calculate, and page through, and you'll have all that data. So we have the mean and the standard deviation for x, mean and standard deviation for y, and we take each data point. So we take 12, we're going to take 12 minus our mean, 19.2, divided by our standard deviation, which is 7.04. Then we're going to take 15 minus 19.2 over our standard deviation. Then 17 minus 19.2 over our standard deviation. And so on through the whole data set. Now, for our y variables, we have to do that, but with 12.4 and 2.7. So we just do that across. Um, hopefully you're getting the point by now that this isn't something that people love to calculate. Uh, and now what we do is we take each of these values and uh, we multiply these two values together and and then for each of these data sets, and then we add them up. It's a long process. By now I think you're probably saying, wow, I don't ever want to do that. Good thing you don't have to. We get to do it on the calculator. So what we do is first things, every time you do this, you have to hit second, or not every time. Every time you change your batteries, you have to turn on your diagnostics. So second catalog, and then just hit D or page down to the D's and go to diagnostics on, which I skimmed right by. Hit enter, enter, and now your diagnostics are on. So now if I want to go back and deal with this data, since I have that in my L1 and L2, I can just do a linear regression. Same thing again with my L1 and L2. And when I do my linear regression now, you'll see I get an R value and an R squared value. Now, those are values that we'll be using. So our R value is 0.97, which is a very strong correlation between those two variables. Now, there's some properties of R. If we switch the explanatory and response variables, so if we just flip the x and the y values, the R value doesn't change. It doesn't affect it. Also, if we change the units in a data set, that doesn't change R. It's typical for AP to ask a question like if we changed the units from inches to centimeters, how does that affect R? The answer is just doesn't change it at all. If R is positive, it means there's a positive correlation, and if it's negative, there's a negative correlation. R is always between -1 and 1. If it's closer to 0, it's a weak correlation. If it's closer to 1 or -1, then it's a stronger correlation. This is another thing, correlation, the variables have to be quantitative. You can't take the correlation of position you play on a football team and your height, because the position you play on the football team is a categorical variable. You can't do correlations with categorical variables. Also, correlation doesn't describe curve relationships. We'll talk more about curve relationships and what we do with that. And it's not resistant to outliers. So a couple major outliers can really throw off your R value. And finally, correlation is not a complete summary. Just because there's a correlation, that's not the end of your data analysis. There's much more that you can talk about um, and find more information from. Now here's a small data set. I want you to plug that in and find your correlation coefficient or your R value. Good luck.